guys were having trouble with your homework, what I just told you is that you want to get everything in the form, like every vector in the form magnitude, so like vector v times cosine of theta, like the magnitude of v times cosine of theta, comma, vector magnitude of v sine of theta. So if you get every single vector in that form, then you can add like the plane's vector and the wind's vector and get the resultant vector, like the plane as being affected by the wind. All right, so that's kind of the key to doing these problems. And it's really not that bad once you figure this out. So it says an airplane is flying on a bearing of 340 degrees at 325 miles per hour. Now be careful, when we have bearing, that is not a standard angle. So I always draw a little sketch and I think about what 340 degrees was. So if I'm starting here and I'm going around 340 degrees, right, I'm there. That means I have a little 20 degrees right here. So my standard angle would start from the positive x-axis and go counterclockwise back to that vector, okay?
So 70.
Yes, not 70. What's it going to be?
It'd be 110.
110, exactly. So it's going to be 110. So if you want to like cross it out and write 110 degrees or something so you remember that, that's fine. You can do that if it bothers you, if you're worried that you're going to get confused. So we're definitely going to have like a cosine of 110 and we're going to have the sine of 110. Okay, what is the magnitude?
What would be 325?
Yeah, magnitude is usually the speed on these problems. So 325. I mean, yes, it is the speed on these problems, but maybe it's something else, a length on other problems. All right, so we have that. And this is going to be the plane's component form. Okay, we're going to go ahead and find these numbers. So you can find them, because it says find the component form of the velocity of the plane. I would go ahead and find it. So I'm going to do 325 cosine of 110. So when I do that, I get negative 111.157. And then 325 sine of 110 is 305.400. Okay, so that's the plane's component. So part B says find the actual ground speed of the plane in the direction of the airplane. So in order to do that, we need the vector for the wind, okay? Let me just do it on this page while I have all the information in front of me. So that was part A. So the wind, really I should do like a little vector thing above it. All right, so our wind is going to be, let's see, it says it's a bearing of 320 degrees. So 320 is going to go around. How much room is going to be left? 40 degrees, yep. So you're going to have a total of, like Ayaya was saying, 90 plus 40, which gives you 130 degrees. So that's what we're using. So it's going to be 60 miles per hour times cosine of 130. Oops. And then 60 miles per hour times sine of 130. So are the winds. And you can find what those numbers are as well. Oftentimes I don't actually find these, I actually just add them together in the cosine form, which I'll show you. But if I asked for the components of the wind, I would probably put the decimal approximation. And it should always like point in the direction that you thought it should. Like the wind was going in this direction, right? Wouldn't that be a negative number and then a positive number for the vector? Yeah, it's in the second quadrant. All right, so we put these together. So part B says find the actual ground speed of the plane and the direction of the plane. So in other words, if the plane speed has increased or decreased because of the wind, it has to adjust for that. So find the direction and how fast the plane is traveling with the wind. So what we're doing is we're doing the plane plus the wind. Okay, and when we add vectors, all we're doing is adding their components, right? So I'm going to write it out kind of the long way. I have 325 cosine of 110 plus the component for wind was 60 cosine of 130. And then the next one was 325 sine of 110 plus 60 sine of 130. Okay, so see how we're just adding those two components? I can go back to the other page and show you. Like I'm adding this, and I'm adding this and this. That's all I'm doing, just adding the x components and the y components. Okay? And I usually just do that kind of all on my calculator. So do this along with me because I'm going to show you a trick that's going to save you a couple minutes for each problem. All right, so go ahead and put in 325 cosine of 110. Make sure you're in degree mode.
I thought it was 425.
What did I do?
325?
Is it 325 or 425? Yeah, it's 325 miles per hour. All right, so I put in 325 cosine of 110 plus 60 cosine of 130, and I ended up getting negative 149.734. And I store that value, so store it as A. So stow A. Okay, if you don't know how to do that, kind of ask a neighbor. Store alpha A. All right, now notice how I've already put in the 325, the 60, the 110, the 130. I've put all that in. I just need to change all the things to sign now, right? So that's when I do second enter. It pulls up the last thing you had, which is probably the part you stored, so hit clear. And do it again, second enter. Now do you guys see how you can adjust and you can make it sine instead of cosine? So that number is 351.363. All right, and we're going to store that as B. So stow alpha B. Okay, so the question is find the direction and how fast the plane is traveling. So our direction is going to be theta, and how fast the plane is traveling, that's going to be our magnitude. So now that we have this vector, this resultant vector, right, then we can come up with theta by doing tangent of theta is equal to opposite over adjacent, which is going to be the y value over the x value. It's the b number divided by the a number. All right, so when we do that, we get theta is equal to negative 66, right? Negative 66.920. Okay, so let's think about that. Is that look at our vector. Where would this vector be? It would be negative and then positive, right? It'd be here. Does that negative 66 work for us? Negative 66 degrees would be over here. So what's wrong? Yeah, add 180. So we're going to add 180. So we get 113.080. Okay, and that makes more sense. Now, I wasn't very specific in this problem. I just said find the direction, which to me it would mean like the normal theta, like our standard angle. But if you wanted to call that a bearing, we could also do that. Yeah, you with me back there? Mm-hmm. So if you wanted to talk about the bearing, how would we find the bearing? It's a little tricky. Can you guys think about how to find that? Yeah, basically you would need this angle that goes all the way around to that line. So if you wanted the bearing, I would probably do the 113 number minus 90 to find this little tiny bit here, which is 23.080, that part. And then do you guys see you can subtract that from 360? So it'd be 336.920. That would be the bearing. Do you guys understand that? So if I just said direction, you can leave it as the 113. That's kind of like the standard angle. All right, and then the next thing says how fast is the plane traveling? So I find the magnitude. Do you guys remember how to find the magnitude? Yeah, so you take so the magnitude is going to be the square root of whatever that a number was squared plus b squared. Because we already found the component. We found the x and the y, right? So if I do a squared plus b squared, and then take the square root, we end up getting 381.933. And just like, normal problems, we've talked about this with investments and so on, you think about whether or not that makes sense. Can a plane go 381 miles per hour?
Yes.
Yeah. If I had forgotten the square root, it would be 145,873 miles per hour. No, it's not going 100,000 miles per hour. So think about it, and it's usually very, very close to the number that we had. So see how it was 325 originally? Now it's 381, so that wind is pushing it faster. All right. Okay, so I'm going to give you guys a couple seconds to work on those ones from your homework. So you can discuss with your table, make sure you guys have the same answers. Hang on.